Good morning, student. Welcome my channel Bhuloks Mathematics. Last class I have already discussed about some short answer type questions from different chapter. Let us come and start some short answer type questions from different chapter, which is very important for your coming examinations. So first of all, we have to discussing about the question number 34. Sin inverse 4 by 5 plus 2 tan inverse 1 by 3 is equal to pi by 2. We have to prove it. Okay. So it is a heterogeneous function. So first of all, we have to bring it homogeneous. That means both of them will be converted to tan inverse. How can you convert sin inverse 4 by 5 to tan inverse? So in order to convert sin inverse 4 by 5 to tan inverse, we have to make one triangle, right angle triangle. Write down. This is a right angle triangle. Here it is A, here it is B, here it is C. Okay. So sin inverse 4 by 5 means P is 4, H is 5. When H is given, P is given, B can be found out. 5 square minus 4 square, that is root over of 25 minus 16. Here it is root over of 9, that is 3. So B is coming out. So sin inverse 4 by 5, write down the LHS. Sin inverse 4 by 5 plus 2 tan inverse 1 by 3. Sin inverse 4 by 5 is same as tan inverse P by B. P is 4, B is 3. So that is equal to 4 by 3. So this sin inverse 4 by 5 is converted to tan inverse 4 by 3 by using the right angle triangle. We know 2 tan inverse x, that is one formula. 2 tan inverse x is equal to tan inverse 2x divided by 1 minus x square. This is one formula you have already known. So applying 2 tan inverse x. So tan inverse 2 into 1 by 3 divided by 1 minus 1 by 9. So that means tan inverse 4 by 3 plus tan inverse 2 by 3, here it is 9 by 8. 9 minus 1 is 8. 3 into 3, here it is 4. So tan inverse 4 by 3 plus tan inverse 3 by 4. Applying tan inverse x plus y. Tan inverse x plus tan inverse y. Tan inverse x plus y divided by 1 minus 4 by 3 into 3 by 4. Okay. So 3 cancel. 4 cancel. It is 0. Tan inverse something by 0, that is tan inverse infinity. So tan inverse infinity means tan inverse tan pi by 2. Okay, tan pi by 2 is infinity. So tan inverse of tan bakso is equal to bakso means pi by 2. In place of box, it is pi by 2. So tan inverse of tan x is equal to x. Okay, so this is the answer of question number 34. Then we have to discussing about question number 33. Write down 33. Differentiating sin inverse 2x by 1 plus x square with respect to cos inverse 1 minus x square with respect to 1 plus x square. First of all, we have to take this is a y and this is a z. Our aim is to find out dy by dz. So write down, let y is equal to sin inverse 2x divided by 1 plus x square. So put x is equal to tan theta. X is equal to tan theta. So that is sine inverse 2 tan theta divided by 1 plus tan square theta. 2 tan theta divided by 1 plus tan square theta, that is equal to sine 2 theta. Okay, sine inverse of sine 2 theta is equal to 2 theta. Sine inverse of sine 2 theta is equal to 2 theta. When x is equal to tan theta, then theta is equal to 2 tan inverse x. 2 tan inverse x. Now we have to find out dy by dx. dy by dx. ddx of 2 tan inverse x. That is 2 is constant. That will be coming outside. Derivative of tan inverse x is equal to 1 by 1 plus x square. So dy by dx is coming out. Now we have to take, this is a z. Write down z is equal to cos inverse 1 minus x square divided by 1 plus x square. So let x is equal to tan theta. X is equal to tan theta. So cos inverse 1 minus tan square theta divided by 1 plus tan square theta. So 1 minus tan square theta divided by 1 plus tan square theta, that is cos 2 theta. Cos 2 theta. Cos inverse of cos 2 theta, that is 2 theta. Here it is 2. In place of theta, tan inverse x. So z is the same as this. So dz by dx. ddx of 2 tan inverse x. 2 is constant. Coming outside, derivative of tan inverse x, that is 1 by 1 plus x square. So our aim is to find out dy by dz. dy by dz is same as dy by dx divided by dz by dx. So dy by dx already found out. dy by dx 1 by 2 by 1 plus x square divided by dz dx is also 2 by 1 plus x square. So this is a cancel. Result is 1. So differentiating sin inverse 2x by 1 plus x square with respect to cos inverse 1 minus x square divided by 1 plus x square, then value of is 1. dy dz is equal to 1. So this is the answer of the question number 33. Okay. Now we have to discussing about the question number 32. Fx is equal to ax square plus b if x less than 1 and 1 when x is equal to 1. 2ax minus b if x greater than 1 is continuous at x is equal to 1. Then what is the value of a and b? Okay, we know a function fx is said to be continuous at x is equal to a if LHL is equal to RHL is equal to value of the function. First of all, we have to find out LHL, then we have to find out RHL, then we have to find out the value of the function. So write down, first of all, we have to find out the LHL. Write down question number 32. LHL 32, answer 32. LHL limit extends to 1 minus. 1 minus means x less than 1. F of x. That is limit extends to 1 minus. When x less than 1, then value of fx is ax square plus b. When x less than 1, fx value ax square plus b. So ax square plus b. Then we have to put x is equal to 1. We get x is equal to 1 means a plus b. LHL is coming out a plus b. Now we have to find out RHL. Limit x tends to 1 plus f of x. Limit x tends to 1 plus means x greater than 1. When x greater than 1, value of fx is 2ax minus b. So write down limit x tends to 1 plus, here it is 2ax minus b. So put x is equal to 1, 2a minus b. 2a minus b. As fx is continuous, write down as fx is continuous at x is equal to 1, so LHL is equal to RHL is equal to value of the function. Okay, so a plus b is equal to 1, value of the function is 1. RHL is also equal to 1. Okay, a plus b is equal to 1. 2a minus b is also equal to 1. Now adding plus b minus b cancel. A plus 2a, that is 3a is equal to 2. So a is coming out 2 by 3. When a is coming out, b is equal to 1 minus a, 1 minus 2 by 3, that is 1 by 3. b is equal to 1 by 3. A equal to 2 by 3, b is equal to 1 by 3. Okay, so the value of a and b is coming out. As fx is continuous, so left hand limit is equal to right hand limit is equal to value of the function. Okay, so this is the answer of question number 32. The value of a is equal to 2 by 3, value of b is equal to 1 by 3. Okay, so now we have to discussing about question number 31. This is from relation. R is a relation Mn such that Ma plus n is greater than equal to 5. Is a relation on set of natural number. Verify reflexive, symmetric and transitive. Okay, we have to verify symmetric, transitive and symmetric, reflexive. So first of all we have to verify reflexive. So write down question number 31. R Mn such that m plus n is greater than equal to 5, where m of n belongs to n. Okay, first of all we have to verify reflexive. Write down reflexive. Reflexive. Reflexive means m related to n. M related to n. Ma plus ma. M plus m is equal to 2m. 2m. M plus m is equal to 2m, which is not greater than equal to 50. Okay? 2m, which is not greater than equal to 50 always. So m, mm does not belongs to R. Okay? For all m belongs to n. M plus m, 2m, which is not always greater than equal to 5. Not always greater than equal to 5. Suppose m is equal to 1, 1 plus 1 equal to 2, is not greater than equal to 50. So it is true for all m belongs to n. Then reflexive property is satisfied. So suppose m is, example I am taking, m is equal to 2. Okay, 2 plus 2, that is 4, which is not greater than equal to 50. So reflexive property not satisfied. Reflexive property is not satisfied. Reflexive property is not satisfied. Then symmetric, write down symmetric. Symmetry means m related to n, that implies n related to m. M related to n. M plus n is greater than equal to 5. M plus n greater than equal to 50 means na plus m also greater than equal to 50. M plus n greater than equal to 50 means n plus m is also greater than equal to 50. So na m belongs to R. N is related to m. So n related to m. That means, so symmetric property is satisfied. Symmetric property is clearly satisfied. Then transitive. Write down transitive. Transitive means m related to n. M related to n. That means m plus n is greater than equal to 50. M related to n. M plus n greater than equal to 50. Okay? So n related to p. N is related to p. So n plus p is also greater than equal to 50. Okay? N plus p is also greater than equal to 50. Okay, now our aim is to show that m related to p. Now adding m plus n plus p is greater than equal to 50 plus 50. Okay, m plus p plus 2n is greater than equal to 100. So 2n will go to that side. Okay, so m plus p, write down m plus p. M plus p. M plus p is greater than equal to 100 minus 2n. 100 minus 2n. Okay, 100 minus 2n. So m plus p is always greater than equal to 50. Whatever n be, you have to take one example and verify. So m related to p. So transitive property satisfied. Transitive property is satisfied. Not reflexive but symmetric as well as transitive. Okay, m related to n means you have to take one m and n such that m plus n is greater than 50. And you have to take n plus p, that is also greater than 50. So m plus p is always greater than 50. You have to take one example. Okay, suppose m, I am taking one example, m as 35, n is equal to 25. So m plus n, p is equal to 30. P is equal to 30 I am taking. So okay, m plus n, this is one example. M plus n, 35 plus 25, that is 5 plus 5, it is 0. 3 plus 2, it is 560, is greater than 50. N plus p, n is 25, p is 30. Here it is 55 is greater than 50. Okay, our aim is to show that m plus p, okay, is equal to 100. M plus p means m plus p that will be most minus is greater than m plus p is equal to m is 35. Here it is p is 30. Here it is 5. Here it is 65. Is greater than 100 minus 2 into n. N is here 25. Here 100 minus 25 is greater than equal to 50. Okay, so it is clearly verified. M plus p is 35 plus 30, 65, greater than 100 minus 2 into n. N means I am taking 25. 25 into 2. How much? It is 100 minus 50. 50 is greater than equal to 50. So, transitive property is clearly satisfied. Now we have to discuss about the question number 30. If the position vector of the point P, Q, R, S are 4i cap plus 3j cap minus k cap and 5i cap plus 2j cap plus 2k cap and 2i cap minus 2j cap minus 3k cap and 4i cap minus 4j cap plus 3k cap respectively, then show that P, Q and RS are parallel. We know two vector A and B are said to be parallel if one of the vector can be expressed as the scalar multiple of another vector. Okay, now we have to find out PQ vector. Write down question number 30. PQ vector. PQ vector means position vector of head means Q minus position vector of P. Position vector of Q minus position vector of P. So PQ, what is the position vector of Q? It is 5, 2, 2. 5, 2 and 2. What is the position vector of P? Here it is 4, 3, it is minus 1. Now difference. 5 minus 4 it is 1. 2 minus 3 it is minus 1. 2 plus 1 it is 3. Okay, that means I cap minus j cap plus 3k cap. It is PQ vector. Now we have to find out RS vector. RS vector means position vector of SA minus position vector of R. Position vector of head minus position vector of tail. Position vector of S. Position vector of S is given as 4 minus 4 it is 3 minus position vector of R is given 2 minus 2 minus 3. So here it is 4 minus 2. It is 2 minus 4 plus 2. It is minus 2. Here 3 plus 3 it is 6. So when 2 is taking common, here it is 1 minus 1, 3. So this is nothing but 2 into PQ vector. PQ vector. You see here, RS vector can be expressed as the scalar multiple of PQ vector. Hence, RS vector is parallel to PQ vector. We know two vector A and B are said to be parallel. If one of the vector can be expressed as scalar multiple of other vector. That means A vector is equal to lambda into B vector. Lambda belongs to R. Okay? If one of the vector can be expressed as the scalar multiple of another vector, then at that time two vectors are said to be parallel. PQ vector found out, RS vector found out. Here it is seen that PQ vector is 2, RS vector is equal to 2 times of PQ vector. Hence, RS vector is scalar times of PQ vector. RS vector is parallel to PQ vector. Thank you to all for watching my videos. Please subscribe my channel, like my channel and share my channel.